Welcome back. We are looking at section 7.5, which is strategy for integration. We looked at some kind of ideas that first thing you should look for is simplification inside the integral. And if you cannot simplify, then you should try to look for the specific forms, like or to apply the specific formulas, like the integration by parts formula or the method of partial fractions, and then algebraic manipulation, trig identities. So this is everything that you know of should help you figure out what the how to solve the integral. Now there are some integrals in science that we cannot solve using the algebraic methods. For those we have numerical methods, but we will not discuss those here. The integral that you will be given will always be such that they can be evaluated by using algebraic methods. So here is the example, the one that we did in the last video. So we came to integrating secant cube theta. I mentioned that I will show you this later. So towards the end of this section, I have the secant theta and secant cube theta, the integral of secant theta and integral of secant cube theta. That's what we will do at the end, and then we will come back to this problem one and complete it. So let's look at number 2 here, down here. Okay, so this is simple 1 minus x over 1 plus x, but the square root makes it difficult for us to think about any strategy that we have used before. In the past, if you saw something like x over square root of 1 plus x integral dx, then you were given the idea that you set 1 plus x equal to u, then dx is equal to du. You can find x, which is going to be u minus 1, plug in there and things will simplify and you can easily find the integral. Here though, if we use such a substitution or setting u equal to 1 plus x or setting u equal to 1 minus x, whichever, it will still not resolve the issue. I encourage you to try plugging in, let's say 1 plus x equal to u, for example, and then try to simplify. But you will see that you come to a level where you are stuck and you cannot move further. But the method that we use here is multiplying by the conjugate or rationalizing the denominator. So I will use this method. I will have my integral. First thing I do is I will set the this integrand using the properties of exponents. I can set it square root of 1 minus x over square root of 1 plus x. Okay. So this split we can do. What we cannot do, this is the properties of exponents. So if you have a, basically, so 1 plus x, you cannot write it as square root of 1 plus square root of x. In the same way, you cannot write square root of 1 minus x as square root of 1 minus square root of this you cannot do. But the split over the quotient or the product we can do. So we will now multiply top and bottom by square root of 1 minus x. So that the numerator becomes 1 minus x because square root of 1 minus x times square root of 1 minus x is 1 minus x. The bottom though, now again the property, so these two are being multiplied, will be multiplied, so we can bring them under one square root sign. So we get square root of 1 minus x square. Voila! You see something familiar here? Okay, let's go move further. So I can now split this as 1 over square root of 1 minus x square integral and minus x over square root of 1 minus x square dx. So where do you see this square root of 1 minus x square? 1 over square root of 1 minus x square. What is that? That is the derivative of sine inverse x, which means this quantity when integrated will give you inverse sine x. So coming back, I will now split the integrals. Like will have two integrals. Integral of 1 over square root of 1 minus x square dx minus integral of x over 1 minus x square dx. Now the first one is straightforward, that is just sine inverse x, this one. So I will now look at the second integral. What do I do there? We have to make a substitution. In this one, we say let u equals 1 minus x squared, then du is equal to minus 2x dx. So dx will be equal to du over negative 2x. This is only for the second part. The first part is just sine inverse x. So we end up getting sine inverse of x minus integral of x divided by square root of u times du over negative 2x is equal to, now this x, we cancel the x there, the two x's will get cancelled, this x and this x, and we are left with negative 1/2 first sine inverse x plus this negative here and the negative here. They both combine and make it positive, and 1 over 2 is outside, and integral of du over square root of u. And square root of u can be written as u to the negative 1/2 du. So now this quantity can be integrated. So we end up getting sine inverse x plus 1/2 times 2 How am I getting that 2? I will get this when I integrate u to the negative 1 half, which will become u to the 1 half divided by 1 half, which means multiplied by 2. And then plus c. Now we just go back, replace u by 1 minus x square root. So answer will be, final answer is sine inverse x plus square root of 1 minus x square plus c. Looking at the next problem, I have tangent over secant square theta. Now we have in section 7.2, you might recall you have seen integrals which involve secant and tangent, but they were almost all of the examples that you saw, they both quantities were in the numerator with different powers. But here the denominator is secant square theta and the numerator is tangent theta. Now, if the question was, if it is in the other order, if we had a secant square theta on the top and tangent theta at the bottom, this is a clear u substitution problem. So you can say u equal to tangent theta, and this thing secant square theta is actually derivative of tangent theta. So the derivative is being multiplied for the function, and so we have a u substitution problem. But in this case, in our case, we have the secant square theta is at the bottom and tangent theta is on the top. So we cannot use the tricks that we learned in section 7.2. So what do we do? The other thing which we should have thought first, simplify. So we can convert everything into sine and cosine. So remember, tangent theta is sine theta over cosine theta. And secant theta is 1 over cosine theta. So secant square theta will be 1 over cosine square theta. So when you divide two fractions, the first stays as it is, the second gets multiplied and reversed. We take the reciprocal. So we get cosine square theta over 1 d theta. So we now see that 1 cosine theta cancels with this one cosine theta up here gets cancelled, so I take off the square, so 1 cosine theta is left. We clean up, it now looks like integral of sine theta into cosine theta d theta. So what is that? How do you solve that? Again, you can use the methods you learned in section 7.2. You can say, okay, I have a function and then its derivative is being multiplied right there. So we can use the u substitution. So for example, you can say let u equals sine of theta, then du will be cosine of theta d theta. So if you notice, cosine theta d theta is actually du. So this is du and this quantity is u. So you end up getting integral of u du, which is u square over 2 plus c. So u square will be, so you end up getting sine square theta 1 half sine square theta plus c. That will be your answer. Now if you use cosine theta as your u, if you take cosine theta as you will end up getting a cosine square theta, and then um, some multiple here, some constant quantity over here being multiplied. So is that a different answer? No, because remember we can always apply the Pythagorean theorem to the this one or to the other one, cosine square one, and we will get the answer in sine square. The constant gets it dissolved in the C. Another way of doing it is, I will do it with a different color. So it is by seeing this quantity sine theta times cosine theta d theta. Maybe some of you thought about it. If I had a 2 here, then this becomes sine 2 theta. But if I want a 2 here, I must have a 2 in the bottom. So I put that over here, which is equal to 1/2 integral of sine of 2 theta, which is going to be 1/2. So sine 2 theta will have its derivative negative cosine 2 theta over 2. So will be minus cosine 2 theta over 2. Why over 2? Because of this 2 theta in the argument of cosine. So which is going to be negative cosine 2 theta plus C. Okay, now see, this is cosine 2 theta. Here we were getting sine square theta, or we were getting cosine square theta. So is this answer different? No, it is same. Why? Because remember the cosine 2 theta has can be written as cosine square theta minus sine square theta, or it can be written as 2 cosine square theta minus 1, or 1 minus 2 sine square theta. It has these different forms, so we can go back. So this is, I will stop here and come back and do the next example in the next video.